Welcome to this droidcon talk session called Faster Feedback, Cut Gradle Build Pipeline Times in Half. My name is James Cullimore. I'm a freelance software dev with nearly a decade of experience, specializing in Android development. Having worked on over 40 projects and with a dozen teams, I've learned a thing or two that I hope might be useful for you today. I wanted to give this talk because in the last few projects I've joined, Gradle build times and pipelines are rarely optimized. Even new projects often start out fast, but stay unoptimized over time. In the past, I also accepted long build times for what they were without doing anything to improve it, sometimes waiting up to 25 minutes for a single build. On a more recent project, it went too far. It was a straw that broke the camel's back. The team and I needed faster feedback. I decided to do a deep dive into Gradle and CI/CD pipeline performance, learned a lot, and since then I've successfully applied these improvements I learned across multiple projects. The things I'll be showing you today in this talk are not new, magical, unseen shite, but rather things that are often overlooked and forgotten about by many devs. But first, a moment of silence for all the developers who perished waiting for the Gradle builds to finish. Their coffee went cold, their lunch break ended before the build did. Some even finished Netflix series before the sync completed. Let's pour one out for the brave souls who clicked Build Clean Project at 4:45 on Friday. They never came back. But on a more serious note, why faster feedback matters. We all want faster feedback and less context switching. Nothing's better than finishing your tasks for the day or sprint and moving on to some more fun stuff. One of Gradle's articles, they stated, we assume 80% of local build time is wasted, especially when it's under 10 minutes, because it's not worth the context switch. That means thousands of developers are sitting there, pretty much just watching the little tiny progress bar in the bottom right-hand corner. It's wasted time, and no one benefits, especially considering how often we build each day. Just gotta make sure everything's running right. And this isn't just about minutes lost. In larger teams, running thousands of builds per day, wasted build time can cost hundreds of thousands of euros each year. Slow feedback also delays releases, hurts morale, and stresses developers out, or at the very least, stresses me out. Every extra minute compounds. Longer queues, blocked pull requests, frustrated reviews. Productivity drops. Context is lost, and people start multitasking, which leads to even more inefficiency. Think of it as a tax on your whole engineering team. That little slow build doesn't just cost one person's time, it ripples across the pipeline and schedules. Speeding things up is one of the fastest ways to give your team more capacity without hiring more people. So I'm going to do a little poll. You can take out your phone and scan this QR code, and we can have a look at it maybe after the talk. I'll give you like 30 seconds to be able to do it. I just want to see how long devs are actually waiting on their Gradle builds. So if you can, try and pick an option. If it's less than 3 minutes, less than 5 minutes, less than 10 minutes, and I fucking hope not more than 20, God help you, then you really are at the right place. And yeah, I'll have a look. Huh? Local builds first. There will be a second poll towards the end when it comes to the next section, or the CI section, I would say, where you will also be then have this pretty much same option, or QR code to do the poll. And we'll look at it after the end. That way, then it might be a bit more insightful for everyone to see what everyone is actually having for Gradle builds. Right, I'll move on first. Let's start with some quick wins. These are changes you can do gradually or even within a few minutes. Some are not even worth writing up a Jira ticket for. They are that quick. Just slide them into one of your smaller PRs and hopefully no one notices changes, or except maybe for the build times. They are small, targeted tweaks that deliver an immediate payoff. Think of it like cleaning your coffee machine, low effort, big difference in taste. The latest Google Play requirements now force us to keep things more up to date more than ever before, with Android 15 and 16 support, minimum dependency versions with knock-on effects, and more recently the 16 kilobyte memory page limit. So keeping libraries up to date is easier than ever before because we pretty much don't have a choice. Android Studio updates run smoother now and nearly always bring performance gains. Just the frequency can sometimes get a little annoying. By the way, Android Studio Otter just dropped yesterday, I think it was, in case you didn't see it. The Android Gradle plugin, Gradle and Kotlin are easy enough to keep up to date and lately more recommended to do so due to the massive features they have been releasing. Same goes for Java. You'll see let alone speed improvements, but also many new warnings in your IDE when upgrading, like the lambdas you forgot. And don't forget plugins. Keep them current too. Many get performance updates regularly. I know in some cases this is easier said than done and it can be hard to update some dependencies, but whatever you can update might help to reduce the build times. You can also use Gradle build cost argumentation I mentioned before, and we'll mention again later, to push the changes required to be done. I'll be giving a more solid calculation later. Here are a few small Gradle tweaks that can make a big difference. I won't go too deep into each JVM flag or property because every time I read the docs, I forget 5 minutes later what the fuck they do. But in short, they work. You could do as I do and just YOLO them in to each project and just see what happens. Or better yet, test each one individually, especially on larger projects with tight coupling. The benefits vary a lot based on your module graph and dependencies. Here's a brief explanation. JVM args is basically telling Gradle's JVM how much memory to use and to use a faster garbage collector. If your builds are huge, increasing heap size avoids these dreaded out-of-memory errors and can speed up compilation. Gradle caching enables Gradle's build cache, obviously. This reuses outputs from previous builds, which is huge for CI and for switching branches. It's basically free speed. Gradle parallel lets Gradle run independent tasks in parallel. If you have multiple modules or tasks that don't depend on each other, this is where the magic happens. Configure on demand only configures modules needed for the current task instead of all modules. Great for large multi-module projects. And the non-transitive OR class stops generating that giant OR class with references to every resource in every module and reduces the build overhead and speeds up incremental builds. These are quick wins, very quick. Add them one by one, measure the difference, keep what helps, revert what doesn't. Gradle's performance tooling can help you here, and I'll be showing you that later too. Some other options that may help are as follows. Activating the Gradle daemon, which is active by default but might be set to false in some of legacy projects for whatever reason. And Gradle by default logs everything. And while it's great for debugging, it also clutters your console and can slightly slow your build, especially on CI where writing logs to disk takes time. This isn't going to cut your Gradle build time in half, but every bit of input-output you don't do during a build can add up, especially on slower disks or in cloud CI environments. Plus less noise means easier to spot real issues. You don't drown in this configuring X running Y logs. Gradle runs many things in parallel, but not everything shares the same thread pool. The max workers property controls the worker API pool specifically. By default, Gradle guesses based on your CPU. But on CI or a build server, you often want to explicitly set to measure consistency. While I was doing research, I came across Roel Galanz, and I'm really sorry if I'm butchering your name, write-up on common Gradle misconceptions. Many of us assume that Gradle flags or configuration options do exactly what we expect, but the reality is often more subtle. The parallel flag myth you might disable, but tasks that use the worker API will still run in parallel. So disabling parallel doesn't mean strictly serial execution. This matters when diagnosing build time. Just because your parallel flag is off doesn't mean there won't be parallelism. It's actually the first time I've said that correctly. The daemon myth, many assume the daemon handles everything, but builds spawn several JVM processes. The wrapper or client, compiler daemons, workers for tests, etc. Understanding this helps with tuning memory and garbage collection settings. Then there's the composite builds myth. A lot of teams assume that if you set something in the root gradle.properties file, it flows automatically into all included builds via composite builds. That is not true. Included builds execute in isolation unless they explicitly override or share configuration. If you rely on shared settings, you need to manage them explicitly. Groovy versus Kotlin DSL. This one was a bit of a surprise, as I wasn't expecting it until I did some research after a Groovy to Kotlin DSL migration, which I had completed. Groovy is generally a bit faster than Kotlin DSL, although there are reports online claiming this is bullshit. Just to warn you. In 2 of the 3 migrations I completed, build time went up by just over a minute. What could be the cause of this? One thing could be due to Kotlin DSL having overhead. Every time Gradle configures the build, it compiles the Kotlin files before executing. This introduces an initial delay. I can't say that the migrations were fully Kotlin DSL's fault, as some other changes had to be made during the migration due to some weird shite with things like JFrog and Gradle modulated files. A little weird. Anyway, these changes also could have impacted the time, but the fact remains. The migration slowed down the build times. I still prefer Kotlin DSL for readability and safety and would highly recommend migrating, but it is something to consider if speed is critical. When it comes to repository order, it actually matters. Gradle searches them from top to bottom, so every time it needs a dependency, it walks through each repo in order until it finds it. If you have Maven Central after some obscure repo, Gradle will try that obscure repo first for every dependency, which means extra network calls, timeouts, and wasted seconds. Best practice, put Maven Central first, then Google, then anything else you really need. Gradle plugin portal should be last, unless your project relies heavily on it. It's rarely the main source for your artifacts. Removing unused repositories also matters. Over the years, people add test repos, company internal repos, or plugin repos that nobody remembers. Each lookup adds latency. The easiest way to test this, just comment out a repo temporarily and run a build. If it doesn't break, you didn't need it. It's like spring cleaning for your Gradle config. Also remember, even if Gradle caches metadata locally, it still checks for updates. So fewer repos is fewer checks, and fewer checks means fewer DNS and HTTP requests. This is one of those tweaks that feels trivial, but on larger projects or on CI, it adds up quickly, especially when combined with parallel downloads and caching. If your CI agents are on a network with higher latency, every unnecessary lookup multiplies the slowdown. This is free performance. Avoid dynamic versions. Dynamic versions can be convenient during development, but as you don't have to manually bump versions, but Gradle will check for updates every build, which can add several seconds or more per dependency. For production or even normal development, it's much faster to pin exact versions. This allows Gradle to reuse cached artifacts, skipping unnecessary network calls. If it's a small tweak that can save noticeable time on large multi-module projects with many dependencies. Every cached artifact counts when builds are repeated dozens of times a day. Think of it as choosing stability and speed over spontaneity. You still get updates, just on your own schedule, instead of Gradle forcing it every single build. And if you really need dynamic versions, like testing a snapshot or a beta dependency, you can use the cache dynamic versions for property inside your resolution strategy block to control how long Gradle caches the metadata. That looks a little bit something like this. I would recommend also just to double check afterwards as well if this is the correct way or if it can change the minutes and such. I didn't research that at the very least. But yeah. If you are using annotation processors like Room, Hilt, or Fumashi, this one is big. Switch to KSP if possible. Capt works by generating Java stubs from your Kotlin code, then running the annotation processor on those stubs. That means extra compilation, extra disk input and output, and generally slower incremental builds. KSP, on the other hand, plugs directly into the Kotlin compiler, no stub generation, less overhead, faster builds, especially on large projects with lots of entities or Dagger modules. For example, Room plus Capture on a medium project might take tens of seconds per incremental build, while KSP can shave off a significant chunk of that. Switching isn't always plug and play. Some libraries may require migration or a newer version, but if speed is important, it's definitely worth evaluating. If you want your debug builds package time minified, restrict locales and resource configurations. This reduces packaging time, especially when you always test on same devices or emulators. When your app has loads of images and language support, you don't need all of them every single dev debug build. This can shrink your APK and AAB and speed up packaging by a lot. That'll look something like this. Oh, wait, it is rather. Managing third-party libraries and their transitive dependencies is essential, but it can also introduce unnecessary overhead. Unused dependencies can pile up over time, especially during refactors, and they add both maintenance costs and longer build times. If you can remember to remove unused dependencies, yes, it's stripped away in a release build with Minify enabled, but it will still be downloaded and cached by Gradle during builds. Avoid pulling in entire libraries if only a few methods or classes are needed. If possible, consider implementing the required functionality yourself. And also, there's an open source plugin called Dependency Analysis Gradle plugin. That is great for detecting unused dependencies. Highly recommend trying that out. In regards to performance monitoring SDKs, there are some debate online about whether the SDKs like Firebase performance monitoring slow down builds. I myself haven't seen proof, but it's plausible because they at the very least add more code to compile, shrink, and dex. A few people have reported performance issues online, but again, this doesn't mean it's necessarily the case for everyone. The point is, even if build slowdown is minimal, you don't necessarily need these SDKs in every single dev build. Having them active all the time makes your dev loop heavier. A common pattern is to have QA or staging build variant with all the bells and whistles. Performance monitoring, analytics, leak detection, while keeping developer builds lean for faster iteration. This also helps you isolate performance issues in production versus development. It's not about never using these SDKs, it's about activating them strategically. If you suspect one of these SDKs might affect your build time, measure it. Do a build, with and without it, and then compare it. This gives you hard data. If you're running Android Studio on a Gradle on a 12-year-old laptop with 4 GB RAM and a spinning disk, don't be surprised your build takes forever. Gradle can't magically make your Core 2 Duo feel like an M3. Sorry. Even modest upgrades, SSD instead of HDD, more RAM, newer CPU can cut build times dramatically. If you think it costs too much to get an upgrade, then let's do the math. I know it's up there quicker now, but if you save 5 minutes per build and you build 10 times a day, that's 50 minutes saved per day. Over 20 work days, that's 16 plus hours back per developer. At €50 an hour, which is actually very small for a developer's hourly rate, that's €800 per month per developer. So yes, a faster laptop or CI runner pays for itself pretty quickly. Even if budgets are tight, it's worth calculating. This helps sell the idea to management. If you're stuck on slower machines, consider off-building builds to CI with beefier agents to at least speed up feedback loops. So here's the quick wins summary. Update your tools, such as Android Studio, Android Gradle plugin, Gradle, JDK, Kotlin, and upgrade hardware. Enable daemon, parallel, caching, config on demand in your Gradle property files. Compare Groovy versus DSL if you're considering a migration, and use KSP not capped. Optimize repository and dependency declarations and limit local resources. The things that gave me the biggest bang for its buck in this section are the Gradle property changes. Definitely a very quick thing you could achieve in just a few seconds. Just literally throw them in, they're there. In projects with long Gradle build times, and without these changes, every time I have to press that Gradle build button, a small piece of me dies inside. And of course, all these previous tips and tricks also have a positive impact on your CI/CD pipeline. But there are plenty of other configurations in your pipeline you can consider, and we'll get to that, why it matters, in just a second. Just like local builds, we wait for feedback from our pipelines. While context switching feels more normal here, it still carries a similar cost issues as local builds. Gradle claims instead of sitting idle 80% of the time, like with local builds, here it might be closer to 20%. But pipelines often run longer, so the impact is still significant. As a developer, it's frustrating to start your task only to find out 20 minutes later that flaky tests from your previous task have failed, and now you have to go back and fix them. Then you forgot where you were, what you were doing beforehand. That's why we can apply many of the same optimizations we use for local builds, along with some CI-specific improvements to get faster, more reliable feedback. It's another QR code for you to add in this. Not this time, it's not for your Gradle build locally, but rather your CI/CD pipeline times, the average wait time you would have. And as soon as the talk is over, then we can have a quick look at all the results so that we all have a bit of insight how long everyone's waiting. All right. So one thing I've seen a few times is teams splitting your pipelines into lots of small stages, each running only one or two jobs. By default, stages run sequentially. Each one waits for the previous to finish before starting, but many of these jobs could actually run at the same time. It's much faster to see both the linter and tests fail together than to fix the linter, push, wait for feedback, then discover the test fails, fix them, push again, and then wait once more. And I hear, but you can run Gradle tasks locally first. Sure, you can, but you can run everything locally before pushing, but it's not always practical. If you're forced to run everything locally every time, why do we have these pipelines? The more stages and jobs you add, the longer this loop becomes. The solution: collapse them and run in parallel wherever possible. This alone can drastically cut down build times. That one change took a project's pipeline from 12 minutes to 6, with no loss of coverage or visibility. The first 6 blocks, here on the left, these 6 blocks, were turned into 2, which is then this one here. And we combined the first 4 stages and the last 2 stages and just each one into a single stage. The best thing is, this technically can take only a few minutes if you know what you're looking for. If you can, divide tests, linters, and other Gradle tasks across multiple runners or even separate machines. For example, if you have a lot of modules running integrated tests, then split the modules into their own job to run in parallel. Just make sure jobs don't share state, like writing to the cache or database, because otherwise builds become flaky. And be careful with variants. In one project, pipelines were running every build variant by default, plus tests and linters on every module. Even though the pipeline was only designated to build and test a single module, by specifying variants and modules properly, we could cut the time by more than half in this instance. This was actually a very recent discovery, like 2 weeks ago, and I'm genuinely still waiting for access to adjust this on Bitrise for the project. I expect some of the runs to go from 20 plus minutes down to 10. And all it is just adding a single configuration to Bitrise which just says, use this module or use this build variant. That's it. When running on builds on CI, the Docker image you use can make a surprisingly big difference. Slim images are smaller, which means they download faster, start faster, and use fewer resources on the agent. Even if each image only saves a few megabytes, multiply that by dozens of builds per day and many team members, it really adds up. Most managed services like Bitrise, GitHub Actions, or GitLab runners already provide optimized images, so you don't have to do anything here. But if you're defining your own CI image or using an old image from a previous project, this is low effort optimization. Here's a small tip: start from an official Slim or Alpine variant wherever possible. Remove unnecessary tools or SDKs to keep it lean, and a leaner image also reduces caching overhead. Smaller layers means faster cache checks and restores, further speeding up your builds. Downloading Gradle or dependencies every run is slow. share caches across pipelines, push once, pull many. This is a pretty standard and common way to shave off minutes of a pipeline, and there are plenty of guides out there on how to achieve it. So I won't be covering this. However, I have worked on a few projects where we didn't have access to any means of caching outside of a single run, meaning the Gradle was being downloaded every time and not shared across states. And I managed a little weird trick using a delay to reduce a single stage by a minute. I covered it in my article. I'm not going to cover it here. If you're interested in learning more about that, I will share a link at the very end where it's covered. If a pipeline doesn't need build artifacts, don't upload them. Reducing artifact uploads can save up to 30 seconds per job depending on the size and amount of artifacts. Yes, it's nice to have them when you need them, but really consider when you need them and maybe creating a separate pipeline to just upload artifacts on demand or when certain prerequisites are met, such as having a release tag. There is also the possibility to define optional stages that can be started by manual execution in the event that you do need it. So here's the section summary. Parallelize independent jobs, tests, independent jobs, tests, and builds. Merge trivial stages to reduce idle time. Specify build variants and modules where necessary. Cache dependencies, artifacts aggressively, and use lightweight images and right-sized runners. The biggest bang for your buck here, other than caching, of course, is collapsing the stages in a pipeline. This alone takes only a few minutes and is pretty easy to do. It's also something that's often overlooked. Measure twice, cut once. Something I learned in school while doing carpentry that kind of stuck with me, and it kind of applies here too. And I wish I could follow this advice more than I actually do, and you'll see why in a second. To measure, we can use the build scan or profiler to record initial build times, which collects metrics such as total time or slowest tasks. This is, as far as I know, the easiest and most reliable way to get your metrics, to which I only fucking discovered while preparing for this talk. If only I could do my research as good as I build fences. I build magnificent fences, by the way. For example, here you can see the command I'm using along with the profiler argument, done on a reasonably small project with not too much in it. I added the gradle properties shown from one of the very first slides, the caching in parallel, just to show you what difference it can make even from the start. Measurements before showed here on the left 3 minutes 15 seconds, and after adding the gradle properties, just YOLO'd it went down to 2 minutes and 28 seconds. It's already 45 seconds saved. Nearly 45. More than 45. As an alternative or addition to profiling, you can use a simple Markdown file or Excel table to record what was changed and its effect. This will keep a simple and nice overview of the changes you made without having to scour through your commit messages. The values you see here are just dummy values, but it would be nice to have near consistent 1 minute build times or 5 minute pipeline runs. But the idea again is just to show you how to track the changes and keep them in a very simple overview. Again, having known about the profile prior to this would have been really nice. When you make the changes, don't assume every change or tip helps or is right. Benchmark before and after. Build times vary. So get the average of multiple builds and clean between runs. Only then can you be certain that your changes are actually making a difference. All the configurations, tips, and tricks don't apply to every project, so don't be going using them blindly. Make sure to have a baseline before starting, and each change should be recorded to see if it has an impact. If your CI metrics to monitor build times over multiple commits rather than each time, this might be difficult to truly narrow down the changes on a main branch, whether they have an effect, as the changes to the source code may also influence the times too. If you can, make the changes to a separate branch and run the pipeline a few times a day manually, making a single change each day. This may take longer in total, but it's with minimal daily effort. Try and start first with what you think may have the biggest impact and work down from there. Together with your team, you should decide an acceptable build time limit for the project so that you stop making changes once you've reached this, or in case it exceeds, to jump into the possible causes or investigate when trend changed and to further evaluate more reductions. So here's some final takeaways. Measure first. Know your baseline, use the build scanner profile. Start with the easy wins, parallel caching, tool updates, and collapse stages. Iterate and verify. Use the tools to see the real impact and record the changes you made. And most of all, value developer time. Even small speed ups pay off big. If all else fails, we have some Android Studio plugins that can, at the very least, lighten the mood. As you can see, there are plenty of different progress bar plugins to choose from. I think up to 139, if I'm not mistaken, from Nyan Cat to Pokemon, Teletubbies, and even Barney the Dinosaur. In one team, we installed the Super Mario progress bar as a bit of an inside joke, as we had a team member called Mario. Also, I really hope, where is it? I can't see it now. Down here. McDonald's. I also really hope the McDonald's one isn't from the actual McDonald's team. And if they're forced to install it, although that would be very funny, I find in that case. At the moment, I'm using one from Coding with the Italians, as I find it funny to watch a screaming pizza running left or right across my screen. I get a giggle out of it every time. They open sourced the plugin so that you can build your own one based off of it and record it as they were building, which can also be very funny, explaining a lot of different things along the way. Highly recommend taking a look. A link will be shared now in a sec. That's it for the talk itself. Up on the top right-hand corner is a QR code which points to the exact same URL down here in case you don't trust the QR codes. You've already been scanning the QR codes, so banner. And it shows all the sources and reading materials used for this talk. Make sure to check them out, as a lot of them are great reading, including mine. And also make sure I also included some projects for reference, such as Pokedex from Skydoves. I use that a lot to basically just see what's kind of randomly changed. It always has these pretty cool things inside it. And of course, the repo and video from Coding with the Italians. My 2 articles where a lot of the talk content comes from is also linked there. Not everything was covered there, and just like not everything is covered in this talk, so it's vice versa. If anyone has any questions, now is a great time to ask. Otherwise, you can always approach me afterwards, email me, or even message me on LinkedIn. Thank you very much.